The majority of gas-fired room heaters, which are in use and sold in the EU countries even today, have a serious defect. This defect is a lack of the flue gas damper in these units. On the other hand, the use of flue gas dampers can be found in solid fuel furnaces in general to get good appliance efficiency at low power of the heater. The gas room heaters heat the streets at an average of 20% of their power because of the lack of flue gas dampers in these heaters. Flue gas damper is inserted into these new kind gas room heaters, which prevents too much air to pass through the combustion chambers of these heaters. This modification results in the reduction of annual gas consumption by 15 to 23%. This new invention is safe because a butterfly valve of the flue gas damper is fixed on the lengthened spindle of the gas tap, so the higher resistance position of the flue gas damper is mechanically linked to the smaller gas flow, and there is no chance that the users change the factory settings. The diagram shows a conventional gas room heater's efficiency performance as a blue curve depending on the performance of the heater. The red curve shows the efficiency figures of these gas room heaters with a built-in flue gas damper. The 85% measured appliance efficiency at the maximum power is labeled as point C. In practice, the heaters with a combined mechanical room thermostat switching between the ignition state position labeled as point A and the reduced power stage labeled as points B, keeping the room temperature constant this way. In average case, 1/3 of annual gas consumption is burned by the pilot flame stage, and 2/3 of annual gas consumption is burned on reduced rate stage. It is possible to see the big difference in the seasonal efficiencies if the heaters switches between the red A and the red B points, or if without flue gas damper, which switches between the blue point A and the blue point B. The full power of the appliance is only needed rarely in heating up processes when the room is cold. The figures on the diagram clearly show how serious is the impact of the combustion airflow control on the annual gas consumption and on the carbon dioxide emission. It calls the attention that there can be a very big difference between the seasonal efficiencies of two gas heaters, which have the same appliance efficiency at their full power. The flue gas damper, accurately a gas combustion air ratio device, is operable by a small electric motor, which is actuated by the signal of an outside temperature sensor. The use of external temperature sensors and gas combustion air ratio devices result the most significant energy savings at gas boilers. Thanks to this new innovation, the good results of gas combustion air ratio control can be received in local gas heaters as well. This invention is an excellent opportunity to encourage users to replace their old and wasteful heaters to new economical ones. This also gives a new opportunity for the manufacturers of these heaters to produce much more such devices.